Hello all. In today's lecture we are going to see context-free grammar. Under that we will see some problems. Problem is find the string AA 3 times B from the given context-free grammar. This is grammar given to us and we have to check whether we can get the AA 3 times B from the given grammar. We have two types. The first type says that it's a sentential form. Second is tree format. Tree is parsed tree. So from given grammar we can derive this string with the two different formats, sentential form or parsed tree. So we'll try to draw the parsed tree and we'll see whether we can draw the given grammar for the language AA 3 times B. So let's start for the answer. S will be the starting state. S will be the starting state. S is going to produce X and Y. S is going to produce X and Y. X will be the left child, Y will be the right child. Now after this production, we will have two different production X and Y. In the left side, what I required? A. I required A. So check, can I get A to the leftmost? Yes, X is going to produce A. That can be produces for the A. So I will take A. Then see, for the first A I have finished. Now we are looking for second A. Second is not possible because it's a terminal symbol. Once you go to the terminal symbol, after that there is no productions. For recursive production, we have to use the non-terminal symbol. Let's complete the left side. Now we'll go to the right child. Right child is capital Y, and what I am looking for? I am looking for A. So Y is going to produce X and Y. Y is going to produce X and Y. So let's check, can we generate A? Yes, the X is going to produce A, so I can have A with the X. Now I required, after second A, I required B. So Y can produce B directly. Y can produce B directly. If I use this, what is the length of string? What is the language? Language is A, after that A, after that B. But what is my requirement? My requirement is AA 3 times B. And what is here? Here is AB. So this is wrong tree. So with the other format, we'll try to draw X. X is going to produce X and Y. Y is going to produce A. Y is going to produce A. With the Y, I can have Y is going to produce X and Y. So this X is going to produce A. For this Y, what I can occur with the Y, I can occur with X and Y. I can occur with X and Y. And for this X, X can produce 2 times Y and Y can produce B. See here, I have 2 A's. What I want? I want 3 B's. So for 3 B's, if I will produce Y with XY, and the X is going to produce YY and Y will produce B. So if I go here, Y will produce and Y is going to produce B. Y is going to produce B. So this Y will produce B, this Y will produce B, this Y will produce B. B is a terminal symbol, A and B. When we reach to the terminal symbol, then we are going to stop here. So read the string carefully. We have to read from left to right. With the leftmost, I have A. I will come to the right side. With the right side, go to the leftmost, I have A. Go to the parents. Go to the right side. Go to the left side. Go to the left side, B. B is there. Come to the top. Go to the right side. What I will read? I will read B. I have completed this part. Go to the parent. Parent will go to the right side is Y. Y is going to produce B. So what is language I have generated? L equal to 2 times A, 3 times B. So this is the parse tree. With this parse tree we can generate 2 times A, 3 times B. If the question is, can we generate double AB? Can we generate double AB? Yes, we can generate double AB from using this parse tree. Can we generate 2 times A, 3 times B? Yes, we can generate 2 times A, 3 times B with this parse tree. So we can derive the language with two different types, either sentential form or tree form. For this given problem statement, we have used parse tree format and we have derived successfully. So that our answer is, can we find the double A 3 times B from the given grammar? Yes, our answer is yes, we can form the double A 3 times B. Thank you for the listening.